Doctor, what?
Dr. G, Wizz. There's a...
Yes, it was a bullet to the head.
What? Excuse me?
The bullet in his head killed him.
Right. What does the beaker have to do with anything?
Everything! What do you want?
There's a detective on her way to see you.
A what?
A detective. She said her name's Deere. She's investigating this guy's murder and wants to talk to you.
Detective Deere. I've heard of her. She's supposed to be good.
She's supposed to be the best.
Nice theme music.
Thanks.
You must be Detective Deere. So glad you could come down. Glad you're the best.
I just strutted into your laboratory to the beat of a popular Franz Ferdinand song. Of course I'm the best. Now, the murder.
Ah, yes. But I must warn you, it's not a pretty sight.
Nothing phases me. I've seen things.
Uh-huh.
So what's the official cause of death?
Bullet to the head. I just said that. Where were you 5 minutes ago?
Strutting.
I see.
So a bullet to the brain. How does that kill someone exactly?
Are you daft, man? Now pay attention, detective. And you, too. When a large amount of liquid is rapidly displaced, shockwaves will form as the fluid moves to a new location and tries to fit into the new, temporary volume. Due to the amount of water contained within the living cells of our bodies, the tissues react much like water. When a blunt projectile moves through the body, the tissues will form these waves as it tries to compensate for being pushed aside so forcefully. These waves can travel through the body by means of major veins and arteries and other more fluid tissues. These waves cause a massive increase of pressure, up to 10,000 kilopascals. This increase will cause hemorrhaging in the brain and severe nerve damage as the brain is forced to try and make room for the waves.
Groovy.
No, not groovy. Deadly.
Indeed.
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 Next question.
Who is he?
Did you not read any part of the report before you came down here?
Reading the report ahead of time makes me biased. Besides, I was too busy preparing my strut.
His name was Gern Blanston.
That's a funny name.
Indeed.
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 Ah, Dr. Quinton, how are you today?
I'm doing quite fine, thank you. I just came to inquire about the Blanston case.
A bit curious, are we?
You could say so. What was the official cause of death?
Does no one read the report?
Can I just get a straight answer?
Bullet to the head. Do I have to go over the science again?
Please do not.
That won't be necessary, Dr. G. Wizz.
That's a funny name.
Indeed.
Indeed. Indeed.
Is there anything you can tell me about this case now?
Quinton, can't you see I'm busy here? Go back to your test tubes and...
Come on now, it'll take just a minute.
Why are you so interested anyway?
It's just that
Will you stop playing with that stiff?
His arm won't move. Why?
He's in rigor mortis.
Huh?
Rigor mortis, don't you know? As muscles become contracted, they become very tough to move and very stiff, as contracted muscles do not have the ability to flex and move. Now, this is caused by calcium ions permeating the cell membrane. This happens as actin and myosin bind together and pull towards one. It's what's known as contraction, and in which ATP is able to come into the system and release the myosin from the actin. And with the death of an organism, thus ends the process of respiration, which in turn creates ATP. Thus, no respiration, no available ATP to unlatch the muscle fibers from one another. Therefore, the only way for the muscles to ever become relaxed is through the process of decomposition. Through decomposition, bacteria break down the muscle fibers themselves, and in the process break down the contracted muscle fibers. Rigor mortis can be used to determine the time of death, as rigor mortis lasts about 1 to 3 days. Within that window, you can determine the time of death. Anything beyond then, though, is very tough to, I'm probably going to cut the script from there. Rigor mortis is often used in relation when trying to understand the common phenomenon known as zombies. Now, zombies are actually physically impossible because of rigor mortis. Rigor mortis would allow the muscles to be unable to move because there'd be no available ATP for the zombie to function, along with a host of other issues dealing with the transfer of blood throughout the body. Thus, by knowing how rigor mortis works, it is possible to understand that zombies are both physiologically impossible and also stupid.
Now, while it might seem like zombie meat is something that's really delicious to eat, you have to really understand that it is bad for you to eat both human flesh and any flesh really that has begun to decompose, because that will make you sick with bacterial infections. This is Dr. Crystal Marsh.
I should go. I have everything I came here for. It's time that I go investigate the scene of the crime.
Ooh, can I join you?
Sure, you amuse me.
You are not invited.
By the way, I didn't catch your name.
Deere. Deere. Detective Deere.
Well, Detective, you better watch yourself with this case.
Nothing phases me. I've seen things.